This video is on matter and its properties. So we're going to talk about solid, liquid, and gas and their particle arrangements. So first we have to talk about what matter is. Matter is anything that anything that has mass and volume. So to understand what that is, you have to know what mass and volume are. So mass is a measure of the amount of matter. And another way I like to think about this is just how much stuff is there. Some people confuse this with weight. They are related, and we're going to get into that in a second. Volume is the measure of the amount of space that the matter takes up. So I like to think in 3 dimensions, how much space in every direction, kind of how much air does it take up. So matter is made up of atoms, all matter. And that's what a lot of chemistry is about in what we're studying. So, and matter demonstrates the property of inertia, which is the ability to resist changes in motion. So something that has more matter, more mass, more volume will take up more, or will have more inertia. Something that has less matter, less mass and volume will have less inertia. So this is that resistance to change and movement. So for example, a semi-truck has more inertia than a toy car. It's because it's going to be more difficult to start moving, resist change. So if it's stopped to start, or the reverse, if it's moving, it would take more energy to stop it. So, too far. Weight. I said we'd talk about weight and its relationship to mass. So weight is the measure of the Earth's gravity on the mass. So mass is how much stuff there is. Weight is how much gravity is acting on that stuff or that mass. So when I shouldn't say when you, I don't know if you will or not, if you go to the moon, there will still be the same amount of you. You will still have the same amount of mass. However, your weight will change because there is less gravity on the moon. There's less pull towards the moon. So you would weigh less on the moon, but you'd have the same amount of mass. So important to know what this is, the law of conservation of mass. So that word conservation means keeping the same, okay? So when we talk about a scientific law, we're talking about a phenomenon that always happens. We're not talking about the explanation, which is the theory. So the law of conservation of mass states that matter cannot be either created or destroyed in ordinary chemical and physical changes. So we don't live in a magical world. We're not at Hogwarts. All right, so we can't, even in that world, we cannot make anything appear out of nothing, and we can't make anything disappear into nothing so that it literally doesn't exist anymore. What actually happens is that the atoms rearrange, and they can go into different formats, different arrangement of molecules. So with that, one of the possible changes we could have are changes of states. We need to know what our states are. These are also sometimes referred to as phases. All right, so the solid state has definite shape and definite volume. This means that the volume and the shape do not change. So you can pick it up, move it somewhere else, tip it on its side. It will still take up the same amount of space, and it will still keep its shape. So you can see the solid, if I put this blue solid right here in a box, it's going to stay in its solid form. If I move it to the side over here, it's still going to be in that same shape, same volume, same amount of space that it takes up. So your particles are going to be very compact. So if I'm drawing little atoms here or molecules, we're going to have them really tightly packed in a solid like this. Okay, and there's no movement among them from side to side. There's only vibrational movement. Okay, so a liquid, on the other hand, a liquid takes the shape of its container. And it does, though, still have definite volume. So the volume doesn't change. But the shape of that volume will. So for example, you've got your liquid right here in the bottom of this cube, and it's going to be the shape of whatever the cube is. So if I tip the cube kind of on its side, you're going to see a different shape of that water, but it'll be the same volume. Your liquid molecules then, they can shift a little bit. So let me go back up to the solid for a minute. The solids were tightly packed and they could only move vibrationally, but your liquid molecules have a little bit more space in them. So that allows them to move a little bit side to side. So they also have translational movement. This allows them to change their shape, but the volume doesn't change. So the last one we really need to concern ourselves with is a gas. Now a gas takes the shape and the volume of its container. So these little blue dots are these gas particles. Oops. What happened there? And they're going to fill up their container. They're going to move around. There's constant movement. So if I draw my little gas molecules, they are like super spread out. I'm going to draw them like way over here. And they're moving all over the place. That's supposed to be an arrow because they have all of this space. So they have translational and vibrational energy or movement, sorry, just like liquids. But they have more space to move around in. So one last thing to point out is that these two, these two, solids and liquids, are a little bit more similar to each other. More similar. So the last thing I want to reference is plasma. And I'm not talking about plasma TVs or anything here. But plasma, definition is that it consists of charged particles existing at high temps. So we're never going to see this in the classroom. This would be like particles like in the sun. So that is the end.